Okay, everybody. Hi, nice to meet you all. I'm Dmytro from Zebra. I'm going to present to you our technology called ZibraVDB. This technology for compressing and real-time rendering of VDB effects. So this technology consists of three basic parts: compressor and decompressor. This is what optimizes the data because the main bottleneck of VDB is it's just it's big. And decompressor, especially real-time decompressor, is the main part that makes it efficient to work with. And real-time renderer is our own custom renderer for Unreal Engine that we are working on and that optimized specifically for rendering these volumetric effects. Right now, ZibraVDB have two integrations. It is plugin for Unreal Engine, which has compression, decompression, and real-time rendering. We also have a plugin for Houdini. It doesn't have real-time rendering. I will talk about it, why. We also have SDK for custom integration in case you want to bring this type of effect into your own game engine or some other software you have. And we are working on Maya and UD integration next. You could have heard of such technologies as NanoVDB and NeuralVDB and how different they are from ZibraVDB. Like, is it another VDB technology? Well, first of all, NanoVDB doesn't really change a lot. It's just a different layout for volumetric data, which is friendly with GPU, but it doesn't really accelerate anything. It do not allow you to have rendering of VDB in true real time, so it doesn't change much. And Neural VDB, on the other side, it makes even less sense because, yeah, it saves a lot of size, but it's very slow to compress and decompress. So you basically win on size, but you lose on time and you lose a lot. And also, it's still in early alpha, so it's more like a pet project NVIDIA have, and it doesn't change much. So this is why we created a ZibraVDB. ZibraVDB is similar to NeuralVDB, except one thing that it really works. And let's see a short demo. So here you can see two effects. The one on the right is compress effect with ZibraVDB, and the one on the left is original cached using a normal file cache node. This compress effect is compressed using a ZibraVDB file cache node, which is absolutely similar, except it compressed into our custom ZibraVDB file format. These effects have 3 channels, and here how it looks on disk. This is our normal uncompressed sequence, and this one file is sequence compressed. Whole sequence compressed into one file, that's right. And now I can take this file and I can drag and drop it into Unreal Engine. It's instantly imported, and I drop it into the scene and it's rendered right away in real time. We have our own custom renderer. You also can use Unreal's native volumetric renderer, heterogeneous volumes, but it will be much slower. And as you can see, it's just drag and drop setup. You don't need to create all materials. In fact, you can control everything right in your actor properties. And this is just much faster. And you have all the properties you need. You also can control the renderer, the ray margin. The ray marcher, we have all properties exposed, and this is something you can do with heterogeneous volumes. And we also have our own custom reflections implementation. You basically need to select which effect, which object should have reflections, and it's screen independent. So it's fully trace reflection. They use much more optimized renderer. And yeah, it works like that. And you also can have like many copies of VDB because it's really fast. It reacts to all the illumination, it drops shadows, it has everything you need. And yes, that's basically a quick overview of how it works. And now let's go more into details and see how it works under the hood. So first, compressor. Our compressor is GPU-based, so it's really fast. It can also be run on CPU, but it's more for offline use cases when you, for example, have many render farms and you want to render it in offline, then you need to render it on CPU, but in most cases you use GPU. As I said, we compress whole sequence into one file. This is just more convenient to work with. And yeah, this is how it works in Houdini. In Houdini, we have 3 nodes. First one is compress node. Second is decompress node. Compress node just saves your sequence into a file. Decompress node read it back. ZibraVDB file cache node is just a convenient wrapper for these 2 nodes. So in practice, you only use this ZibraVDB file cache node. It's just more convenient. In Unreal Engine, you're also able to import your effects. You should have a VDB sequence. You just select your VDB sequence here. You specify quality for compression, and you press compress, and you have ZibraVDB actor in your asset folder. Compression quality is the only parameter you need to have to compress the sequence. You also can select a different compression quality for different channels. For example, sometimes you want to compress temperature more because you can lose some details. You can afford to lose some details. But in most cases, you just select this one parameter for all channels, you compress it, and you're done. This is some comparison of how effect looks on different compression levels. And because our compression technology is actually lossy, so you will lose some details, but in most cases, on like 30x compression rate, you won't notice much difference at all. So this original, this is 20x. I go back again, original, 20x, 40x, 6x, 8x. Different effects behave differently. For example, some effects, even on 100x, have a really good quality. Some not, it really depends. Also on YouTube, you can watch the same effect, but in animation for different compression levels, and you can watch it in 4K and just see how it looks and how it affects visual look of the effect. This is 40x, 60x, and 8x. But yeah, YouTube decided that you don't want to see it. Okay. ZibraVDB also can compress SDF. It actually wasn't designed to compress SDF in first place, but it is possible, and it does a pretty good job. You need to do some hack in Houdini for that. So first you need to convert your SDF to FOC VDB, and after compression you need to convert it back to SDF. This is because we do not natively support SDF yet. And let's talk about speed. So we have these 2 nodes, a regular file cache and ZibraVDB file cache. ZibraVDB node will be a little bit slower because it has a compression state on top of it, but it's not that much slower because our compression is GPU-based, it's really fast, and it works in parallel with simulation, for example. You can simulate some frame and you can compress at the same time some previous frame. So you doesn't lose on time here. Now let's talk about decompressor. Decompressor is the main part because compressor can be slow. It doesn't really matter. But if you have slow decompressor, you won't be able to do anything with your VDB in a fast way. So our compressor is really fast. It can decompress effects in microseconds, not even milliseconds. But of course, it depends on the size of the effect. And this is the thing that eliminates this bandwidth bottleneck. And this is the most important slide, and this is how it works. Let's imagine you have some ZibraVDB file on your disk, which is just a sequence of frame compressed. Let's imagine you want to render the next 3 frame. You put this 3 frame into RAM. You load it. It's still compressed. It will be really fast to load it on disk. Next, you select the frame that you want to render right now. You pass it to decompressor on GPU, which is, in our case, it's just basic compute shader. And when you decompress it, it stores the data, decompressed data, directly in VRAM. So this is basically how it works in a nutshell. You eliminate a bandwidth bottleneck by streaming from disk, not full frame VDB, but you load from this compressed VDB, and you generate the compressed data directly in your VRAM. And in this way, you don't have wait times for loading just data from disk. But as I said, in Houdini, we doesn't have a real-time playback of VDB. This is why. Because in regular file cache node, you spend most of the time on reading the data from disk. And the other big bunch of the time goes to OpenVDB library work. It allocates the memory, it originates the data, it do everything it needs, but it does it very slow. In case of ZibraVDB file cache, you read from disk really fast because your data is compressed. But after the compression, we actually convert it to VDB in Houdini because all renderers know how to work with VDB. They don't know how to work with some custom volumetric data. So we need to convert it to VDB. And this conversion actually takes almost all of the time. Decompression step here is so small that it doesn't affect performance at all. It's all OpenVDB that we cannot get rid of right now. But what we want to do in the future is to pass our volumetric data directly to renderer. So you will have a real-time preview in viewport of VDB. But for now, we are limited with Houdini API, and we are waiting for them to make some changes so we can really implement that feature, because this will be a big game changer. Some of you might have catched this analogy that ZibraVDB is basically a codec for video, but for 3D video, right? If you have EXR images and you want to play it in real time, you won't be able. Even if it's 2D image, it's not even 3D, but it still be too expensive to render it in real time. So if you want to see it in real time, you convert it to some kind of video. And this is the same thing we are doing with OpenVDB. You just convert your OpenVDB sequence to our custom 3D video, let's put it this way. You still have OpenVDB if you want to work in like lossless pipelines, or you want to store your original data, but in many cases you can just compress it into R format and save a lot of some space. Now let's see how our real-time rendering works. When we started working on ZibraVDB, Unreal Engine only just released heterogeneous volumes, and it wasn't any good, so we decided to implement our own renderer. And then as heterogeneous volumes were progressing, we noticed that it's still much slower than our own renderer. So up to this time, we are still supporting it. And our renderer is much better because it allows you to have full control over your rendering, because in heterogeneous volume, you cannot control anything. Maybe you have some CVARs that allow you to optimize ray margin, but these CVARs are undocumented, and you can only guess what you can do, what you can't. In our case, we expose all rendering parameters, and you can optimize the rendering of each effect separately. We also will have really minimal memory footprint, because in case of rendering volumetric effect, you not just load your effect in memory, you also need to store volumetric illumination, texture, and all need additional data. So rendering volumetric effects is actually memory expensive. And this is something that we optimize like a lot. And also working with ZibraVDB and Unreal is just much faster. You don't need to have all the fuss with creating materials, binding them to some heterogeneous volumes actor, etc. And even if you are using a heterogeneous volume renderer with ZibraVDB, it's still just much faster. So here's comparison. On the left is regular native Unreal Engine volumetric rendering. It is SVT plus heterogeneous volumes. In the middle, we replaced SVT with ZibraVDB. We still use heterogeneous volumes. And as you can see, it's almost 3 times faster just by replacing SVT, because SVT has this bandwidth bottleneck. So it's just slow because it tries to load these full frames from the disk. And on the right, we're replacing heterogeneous volumes with ZibraVDB, and it became even more fast. And all this is taken from the editor, and this is like a minimal FPS on the biggest frame, because it is explosion, the frame grows in the time, so those metrics are on the largest frame. Here is more metrics. I took some like big effects. If you're using ZibraVDB for games, you probably will have something much smaller, but even these effects are possible to render in real time. This is also because our renderer is sparse renderer, so it renders effectively even if your effects have a lot of empty spaces. And yeah. Why we actually support in heterogeneous volume render? This is because we wanted to have this path tracing support. Implementing own path tracer would be actually too slow. Maybe even it wouldn't be possible, but the Unreal Engine already has path tracer for heterogeneous volume, so we added support for heterogeneous volumes. We actually noticed that path tracer in Unreal Engine is not designed to render really big effects. So ZibraVDB allows you to render much bigger effects that you even able to import into Unreal with some standard method. So, but you still can render some good effects using path tracer. We actually ran ZibraVDB on mobile phone too. We decided just to do this for fun, and we ported ZibraVDB to iPhone in like less than a day, most of which we of course spent on drinking coffee and smoking cigarettes. And on iPhone 15, it works in 30 FPS, and this is like without any optimization at all. We're not really targeting mobiles. It just was like fun thing to do for us. Another area of adoption we're experiencing is virtual production, because VFX artists that are using Unreal Engine for virtual production is not actually familiar with Unreal Engine. They are adopting it, but they used to their old pipelines, and they used to work with VDBs, not with Niagara, with Flipbooks, and etc. And with ZibraVDB, they can bring their effect from Houdini into Unreal Engine and use it on big LED screen. Of course, they're using some pretty top-tier GPUs, but at the same time, they're rendering at 15 FPS and in 4K, and often it's 4K without upscaling. And ZibraVDB showed pretty good in these conditions. We actually took this scene and decided to optimize it for gaming. So this scene has actually two effects, this burning car and some volumetric fog you can see. And we were able to optimize it for all PS5 level hardware and have 75 FPS in the whole scene. Of course, we need to have a little bit lower resolution and effect and optimize our performance more strictly. But yeah, it works pretty good on gaming hardware. And also I should say that ZibraVDB is implemented as a plugin. It's not integrated directly into rendering pipeline of Unreal. And because of this, we cannot do many optimizations that we could if we would modify engine source code. But even with what we did already, it's much faster than heterogeneous volumes. And we're actually working on updates that will boost performance 30–40% more. ZibraVDB and Unreal allow you to render 3-channel. So we have 3 slots. Density channel float. Here you put your smoke channel, which is usual density. Temperature float is emission channel for density. It cannot be visible by itself. It's only visible if you have density. So it's like multiplier for density. And flame float is same as temperature, but it can be visible by itself. We find this is all you need for rendering VDB. In most cases, you're using only 2 channels, like density and flame, or density and temperature. Sometimes you can use 3, but yeah, that's more than enough. Let's now talk about features. Illumination of our effect supports 3 types of lights: point, directional, and spotlights. You can have up to 15 lights in the scene. It doesn't really make sense to support more than 50, so we just cut it at there. We are rendering volumes at lower resolution, because this is usually how volumetric renderers works. You don't calculate illumination in full res. This is too slow, and actually it doesn't really have much difference in full res or half res. But you can render it also in full res if you want. We have many features for illumination, like ambient lighting. As I said, you have all access to ray margin parameters, so you can optimize it per effect and all that. We have shadows, 3 types of shadows, actually. Self-shadows, projected shadows, and received shadows. Projected shadows rendered using Unreal translucent shadow renderer, which is not ideal, but it is like 10 times faster for rendering shadows than in heterogeneous volumes, and it does a pretty good job. For received shadows, it's when geometry casts shadows on your effect. We're using a global distance field. This is actually not the most optimal approach, but we cannot access shadow maps in our shader, so we are going with this way for now, but I think we will replace it in the future with shadow map. It will give much better quality and much better performance. As I showed you already, it's reflection. Reflections using their own renderer is a bit more optimized than we use for the effect itself, and geometry can intersect the effect and still have a correct reflections. Also, illumination of the effect preserved in reflections. So you basically just render a copy of your effect on a mesh, but in much more efficient way. A reflection renderer is like 20 times faster than our actual renderer. Emission masking is some important feature we decided to add because in Houdini you have this pyro baked node where you can bake emission for your volume, but it only looks good in Houdini because Houdini does a lot of expensive filtering on the effects, but if you take this effect and bring in some other software, it won't be looking this good. So we implemented emission masking, so it basically allow you to fine-tune your effects, especially if it has emission like backscatter or anything. Also, if you have channels like temperature, which is by itself shouldn't be rendered because it's just the data, it shouldn't be visualized. But if you apply emission masking to it, it will look much better. So it also allows you to get some use of channels that shouldn't be visualized. Now let's talk about SDK. SDK is something that we ship for other companies that want to integrate ZibraVDB into their own software. We ship only compressor and decompressor because most engines have nowadays their own volumetric renderer. So you can just decompress data directly for your renderer. We support DirectX, Vulkan, Metal, all you need. We ship it as source code or as precompiled library, depends on what you need. And decompressor actually, in our case, it outputs data directly into a sparse structure. So it's pretty efficient, but if you have some other organization in your rendering, you can adapt it for your needs as you want. It doesn't have like fixed implementation. And now I want to talk what we're working next on ZibraVDB. So first is scattering. And this is basically, for example, when you fire in your effect, illuminate the smoke. Without it, it looks a bit fake. It can be like simulated with point light placed inside the effect, and you will have the similar like effect. But we want to implement it like natively to make it correct rendering of scattered effects. Next is vector channel support. Right now, ZibraVDB does not support compression of channels like velocity or color. You can do this if you split your vector channels into single channels, float channels, but it's like not the most convenient. We are planning to add support for this channel. We're also working on improving our quality. Also, as I said, right now on different effects, it will have not really predictable compression rate. If you compress some effect with 0.5 quality, you will have different compression rates on different effects. So we want to make it more predictable. So if you, for example, compress it with 0.5 quality, you will get 50x compression rate always. So it just gives you predictability and you know what you get. Next, very important thing we are working on is temporal compression. This is something that video codecs do. So instead of compressing each frame separately, you just compress some like each fifth frame, for example, and all frames in between, you calculate a delta for them. So like what's the difference between them? And you compress this difference, not the whole frame. And this will allow us to get much better compression rates, and it also have additional features. For example, we generate optical flow for our effects. This allows you to have a real-time motion blur for your effects and also frame interpolation. So here's what is frame interpolation. It basically generates on the fly frames that doesn't exist. And you can use it to push your compression rates even farther. For example, you can delete every second frame from your sequence and just generate it on the fly, and you will have twice better compression rate. Also, we are working on compressing VDB to different files, so basically a file per frame. This is mostly for offline rendering use cases when you have some effects that you are rendering on different render nodes. And if it's one file, you need to pass this whole file to each render node, even if it consists of frames that are not rendering. So we want to have this option for you to render it, to compress it into separate frames, separate files, so you can have more flexibility. As I said before, we're also working on real-time preview in Houdini. We need some changes in the API from scientific side. If they, for example, will add support for NanoVDB, then we can decompress directly into NanoVDB, which will be much faster and will speed up rendering workflow. But ideal solution would be decompress the data as it is and pass it directly to renderer, which we cannot do right now because of API limitation. But we're definitely looking into that. Next thing we are working on is geometry compression, which is very similar of how ZibraVDB works, but it works with geometry. Right now we have implementation for compressing meshes. We also will be compressing like point clouds for liquid simulations and curves for hair strands, for example. And this is something that works well with modern GPU pipelines. For example, all these new mesh shaders and amplification shaders allow you to render big amount of data in real time. Right now, you only render it again by size because you have this bandwidth bottleneck. And in the same way, by compressing geometry data, we can eliminate this bandwidth bottleneck and render it in real time with modern GPU APIs. And our compression and decompression executed on meshlets. So it can be parallelized. You can compress multiple meshes at the same time and decompress them at the same time. You can, for example, decompress only the part of the mesh that is visible to you and just keep everything you cannot see in your camera. And we have our real-time simulation technologies, which are already on Unity for like 3 years, but right now we are porting them to Unreal. And this is really cool because you can, for example, take this smoke and fire simulation and you can cache it into ZibraVDB and you just have cached, more optimized version of your simulation. So you basically can create your effects in Unreal Engine. And same for liquid, you can take your liquid simulation, compress it into Zebra Geo, and have real-time rendering in the same way, much more optimized than the raw simulation itself. And yeah, that's it. If you have any questions, you can write on our mail. We also have a free version for students. If you're a student, write us on email and we will provide a free version of ZibraVDB for you. That's it. Thank you.